Hello everybody! Let us try to answer this item from the branch of calculus. Credits to the University of South Carolina for providing me with this item. Find the indefinite integral, the integral of 1 all over square root of x times x plus 1 with respect to x. For a small hint, you can use the U-Substitution method. Pause this video if you would like to give it a try. If you're done with it, let us dive into the solution. There's a lot of candidates for what we can use for the value of u. However, the most viable option is u equals square root of x. If u equals square root of x, then when differentiating both sides, we will get that du equals 1 all over 2 square root of x dx. Now multiply both sides by 2 to get that 2 du equals 1 over square root of x dx. I multiply both sides by 2 since there is a part of the integral that is very similar, or there is a part 1 over square root of x dx within the definite integral. After finding the value of u to be used, we now replace all the variables with x. We replace all the variables x with u and then deal the integral with respect to u. Highlighted in blue is the 1 over square root of x dx, and note how it is transformed to 2 du, and look at the red x, we have u squared equals x, since we have the substitution that u equals a square root of x. So from the given integral, we can actually make it into the integral of 1 all over u squared plus 1 times 2 du. Now everything is in terms of u, then we can deal the integral with respect to u. Now we can simplify the integral. Since we have a constant factor of 2, we can bring it outside the integral. So it suffices for us to get the integral of 2 times the indefinite integral of 1 over u squared plus 1 with respect to u. Let's call that expression star. Recall the elementary integral. The integral of 1 over u squared plus 1 with respect to u is equal to the inverse tangent of u plus a constant. Since from star we have the exact same integral, we can actually get the integral to be 2 times the quantity, the inverse tangent of u plus some constant c. Now we can replace all the variables u with x. Since we have the substitution u equals square root of x, we have 2 times the inverse tangent of u plus some constant. We replace the u with square root of x. We're going to get that 2 times the inverse tangent of square root of x plus some constant c. Now we can just simply distribute to get 2 times the inverse tangent of square root of x plus c. Note that 2c and c are just constants anyway, so we can eliminate the factor of 2 and just replace it by a constant represented by c. And this will be our final answer.